Hi guys, welcome to Explore Learning. Today we're going to be talking about another important topic, and that is how to detect edges. Alright, so today we're going to extract edges from images. So without any further ado, let's go straight to today's topic. The first thing we're going to do is to create the Python script on Jupyter Notebook. And the next thing we're going to do now is to create a title for this script. Let's call it edge detection and extraction. Okay, so let's extract the edges from the image. Mark the cell. Let's run it. Alright, so the first thing we're going to do, we're going to import the libraries we're going to be using in this tag. So import CV2, import OS, import globe. Alright, so let's create a new cell. Let's specify the image path. Okay, equal to the arrow, the raw string. So let's get the images. So let's deal with the car images. So copy this link. If you have been following my channel, this will not be new to you. All right, so it's going to be something you're used to by now. So let's paste it over here. Alright, so we need to do the same. Let's specify where we want to save these images after extracting the edges. Alright, so I've created a folder called new. Okay, so let's delete what we have here initially. Alright, so this is the folder I've created, new. Copy the link. Go back to the Jupyter script, paste it. Alright, so create a new cell. This is where we're going to start performing the operation. Okay, so let's create a for loop, img in globe, globe. Let's return the images in this path. Okay, all of the images. Okay, so let's specify all the images. Okay, now let's create an inner loop, a try loop. Okay, and also let's include the exception in case we have any error. We want to print a message instead of Python giving us the error. Let's say operation not executed. Okay, so now let's specify what kind of operation do we want to perform. We want to read the images because we say image equals to cv2 dot, is that a dot? im read. Let's read these images. Okay, the next thing we want to do is we want to convert these images to grayscale. Remember, if this is the first time you're joining this channel, you can check out my previous videos about how to convert your images into grayscale. Alright, so we're going to do the same thing. Let's say gray. Remember I told you most of the image processing tasks requires you to convert your images into grayscale. Right, so let's do this together. Well, let's say cv2 dot, remember, okay, dot convert, and it's gonna be capital letter COLOR. Now we're going to pass the argument. Now, what image do you want to convert to grayscale? So that's the first question. Okay, so this is what we want to convert to grayscale, right? So we're going to put it there, copy, paste, and then you need to specify the operation. So you say CV2, okay, dot, this time around it's going to be all capital letter underscore BGR2 gray. Alright, so once that is done, the next thing we need to do, don't forget what this task is all about. It's all about edge detection. So it means we're going to be extracting the edges from the images. So let's give it a name. Let's call it edge images. So let's say edge underscore img edge images. So we're going to use this command cv2.canny. Now this is cv2.canny. Now we're going to pass 3 arguments. We're going to actually extract the edges from this grayscale image. So the next thing we need to specify is the upper limit threshold and the lower limit threshold. Okay, so you can play around these values. Okay, it's not a fixed value, you can check, because once you increase the threshold, you actually reduces the amount of edges you're going to extract at the end of the day. If the value is reduced, you're going to have more edges extracted, so you wouldn't want to extract noise. Okay, you want to focus more on the object. Alright, so the next thing we need to do, we need to specify the path where we want to save these images to. We have created this path. We've created the path, so you want to send these images to this path. So the next thing we need to do, we need to create a name for the images. So let's call it file name. So if you're new, if you're just watching us for the first time, please watch the other videos. You're going to get the whole scope, the whole idea of what we're doing now. We started from the very scratch and we're getting to the next level gradually. So let's call this let's call it new edge, okay, underscore, and then we have the plus and the str into bracket I, and then we need to specify the format. So let's say .png. all right, so the next thing we need to do, we need to save this image. So we use cv2.imwrite, then you specify 2 arguments, which is the file name, which is this name, okay, and then the image you want to save. So it's the edge image. So once this is done, the final thing we need to do, we need to iterate it through the whole image. Let's iterate the whole image. Let it go through the whole image. You say I plus equal to 1. All right, so once everything is perfect, let's run the code. Let's go. There's no error, so let's check what we have. Wow, you can see the images, you can see the edges has been extracted from these images. Now one thing we have noticed is we've got a lot of edges extracted. There are some information that are really noisy. Okay, so we need to reduce some of this noise. All right, so let's take a step further. Okay, let's take a step further. So let's go back to the script. Let's carry out one operation before we actually extract the edges. Now what we're going to do is to denoise the grayscale image. We're going to use a filter known as the bilateral filter to reduce the noise in the grayscale image. Now the advantage of the bilateral filter is that it reduces the noise without affecting the edges of the image. So that is the advantage of the bilateral filter. So it preserves the edges of the image. So let's include one line of code before the edges is extracted. So let's call it the noise. The noise equal to cv2.bilateral filter. Okay, so once we've done this, we have to pass 4 arguments. All right, so we have to pass 4 arguments to achieve this. The first argument is what do you want to denoise? What image do you want to denoise? So we want to denoise the grayscale images. Okay, that's the first thing. The comma, you include comma. The first thing you need to pass, you need to also specify the diameter. It means the parameter of this filter. The diameter means we need to decide the filter size. So the filter size is very important. We need to state what the filter size should be. Okay, so let's just play around. Let's use this value 11 comma. So the next parameter is going to be what we call the sigma color. Now the sigma color, it's nothing but the sigma color space. Okay, so we have to set that. So let's set it to a value 17 comma. Now the next argument is going to be the sigma space. It must have the same value as the sigma color. Now the sigma space is nothing but the sigma in the coordinate space. Okay, so both of them must be the same because they control the amount of filtering, that takes place. So this is the parameter that controls the amount of filtering. So the sigma space and the sigma color value must be the same. Okay, so once that is done, we need to do few changes. So when you go over to the edge images, we need to replace something. So let's replace the gray variable that is there with the denoise, because that is the image you want to extract the edges from. Okay, so and then good. So once that is done, then every other thing is perfect. Do we need to change any other thing? No, we don't need to change anything. Okay, now let me keep some of those images. So let's have a new name. So let's call this new edge underscore denoise. Okay, let's have a new name, denoise. We want to compare the images with what we have previously. So let's change the name so that we can have the images stored in the same folder. We don't want to delete the previous image we have, so that we can compare the effect of the bilateral filter. Okay, so let's run. All right, so let's check in our folder. Let's see what we have. Wow, this is wonderful. Now you see the previous extraction we did without the bilateral filter, and then you can see the images from the new edge, the noise. You can see after applying the bilateral filter, you can see the differences. Now let's compare the first image. Now let's compare the first image without the bilateral filter and the one with bilateral filter. You can see a lot of noise has been reduced. Now you can see so much noise has been reduced. Now compare with the second image, compare with the third image, compare with the fourth image, compare with the fifth image. Now with the fifth image, you can actually see the difference. You can see the new underscore edge underscore 5 You can see how noisy it is. It means at this point we're extracting so much information that would only contribute to so much noise. Okay, and then when we apply the filter, the bilateral filter, we were able to reduce some of this noise. So you can play around with the values. Okay, you can tweak the values to achieve your desired result. So this is how we can extract edges from our image and train this image using our deep learning network for computer vision tasks, for every other task you want to carry out. So thank you so much for being a part of this lecture session, and don't forget to share, don't forget to like, don't forget to subscribe. I'll also include the link to the GitHub where you can find this code. Thank you so much.